Hello, everyone. I am feeling very relaxed today because of blush. Because where I have been, I interviewed in multiple companies and I still haven't heard a result. So, after a long while, let's, let's see where we have been in our video summary. I think we were covering firewalls. No, not firewalls, but an application security. In recent time, I started doing some packet tracer lab from this channel, Guru Tech Network Training. It's an excellent packet tracer lab, and you must do these kind of labs in order to familiar yourself with command line interface and the Cisco iOS. It's very intuitive, and the lab of 3 hour and 55 minutes is a complete lab, and I have completed up to 2 hour and 45 minutes around. And after that it actually bugs my mind, so I started making notes. And I also want to share that in order to make these kind of labs, you first have to write a configuration. I will show you on my Cisco packet tracer which I just installed. And by the way, if you don't know, I am still back on the Windows. I think I already said that in video last video. So let's see where we up to. Harsh Verma 5. Now I got 73 subs and 74 videos, which is quite nice. And let's see my last video, web application security API security. Okay, so we are proceeding just through that. Cloudflare. I'm making this video after a very long time, and everything seems like changed. I don't know where I've been. Actually, it's a dark reader extension. That's why everything is in dark mode. I am caring for you guys. I guess you are caring for me also. Let's go to Learning Center. We are at a web application security. So where we were up to, let's see. We have covered around 51 minutes, and let's see on last page on which page we were at. What do API endpoint and clients authenticate? Okay, so we we used to maintain a MD file. Let's see if the file still remains on the Windows system. I don't know that the file remains or not. And yes, for the interview, guys, I started preparing for CCNA. And the point is not that I have stopped making videos. I did make a videos. I did make the far longer videos, much more than up to 3 hours and 5 hours each. But I didn't uploaded it because I felt slightly threatened that the content that I am reading is not open to publish. So I was in substantial hurry or a substantial what's the doubtful should I upload that video or not. So I preferred not to. But if you say certainly I will uh, copy the extracts from this and share my learning with you all guys. Okay, so quickly let's navigate to our notes, which will be in backup. Cause backup development and Cloudflare hash. Yes, this is should be here readme.md. Yes, let me increase the font size so you guys can see. Yes, because I am the author, hence I trust the author. Trust my. And I think this size is fine for you, right? So where we were at API client endpoints security. Let's find it ourselves. API endpoint security. Yes, this is the next article. WASP API security top 10. What is this? our font so you guys are able to see. So OWASP API Security Top 10. The OWASP stands for Open Web Application Security Project. So let me copy this and here. My God, things are not working great. Control B. One second. Control B used to make bold. Control I. So shortcut also get change. OWASP. Okay, which stands for Open Web Application Security Project. Wait, paste it. Okay. What if I then control? No, still opens the Explorer. Okay, I will make the asterisk representational. Okay, so it's a non-profit organization जिसका goal है whose goal is to promote web application security. Okay, it is the one of the organization जो कि which is more widely referenced to OWASP top 10. It's the top 10 biggest security concern for web application. API can fuel competitive advantage, but at same time API can introduce new risk. We already knew that. And let's see the top 10 security concern. First is broken object level authorization. Attacker might try to exploit API endpoint vulnerable to broken object level authorization. They could manipulate object identifier within a request, gain unauthorized access to sensitive data. Next is broken authentication. The authentication is implemented incorrectly. Attackers could impersonate API users and gain access to confidential data. Next is broken object property level authorization. The lack of authorization or improper authorization validation at the object property level could leave information exposed to vulnerable to manipulation by unauthorized people. Next is unauthorized resource consumption. Many API do not limit client interaction or resource consumption. Attackers might generate a high volume of API requests, which is the operational cost and lead to denial of, which is a very basic thing. API must be limited by rate. If it won't, it would be prey of denial of, very basic thing. Next is broken function level authorization. Attacker might send illegitimate or legitimate API calls to an endpoint, but they should not be able to access. Okay, okay, okay. So even if the legitimate user sending API calls, they are not able to access, or they might gain access to resource or administrative function of other users. So this is the known case of broken function level authorization. Next is unrestricted access to sensitive business. Okay, APIs might expose a business flow such as posting comment on website, purchasing a product, or making a reservation. And this is the thing that has been exploited a few days on a ticket booking website when a person actually books a ticket using the JavaScript by exploiting some APIs that is used to book ticket, and he booked the ticket even before the booking begins. Next is server-side request forgery. An API might fetch a remote resource without validating the user supplied URL. For example, a user might provide a URL to upload an image to a social media platform, and the URL might then port a scan within an internal network. Next is improper inventory management. API can expose more endpoint than traditional web application. If the organization do not inventory hosts and deployed API versions, they may leave deprecated API endpoint vulnerable. Finally, the unsafe consumption of API. The attacker might target third-party websites that interact with the API rather than targeting an API directly. They realize that developers often trust data from the third-party API more than the user input. I didn't get it. Attackers might target third party services that interact with API. Okay, rather than targeting an API directly. Okay. So the third party that uses the first party API is being targeted by the attackers, not directly but indirectly. And we have learned about the 9 things. Where is the 10th? There is some crossover between OWASP top 10 and the OWASP API security top 10. For example, broker's access control is the first issue in the OWASP top 10 list, and there are various forms of broken authentication and authorization among the first 5 security issues on API list. In addition, security misconfiguration, server-side request forgery. How does the Cloudflare, let's see what Cloudflare did. It helps API secure, keeping API secure and working as this should to go through API discovery capability, centralizing API management and monitoring, and innovative layer defenses. API Gateway is a part of Cloudflare's application security portfolio, which offers additional capability for stopping bots, DDoS attack, application attacks, etc. Good. So again, Cloudflare is doing a lot in order to enhance the API security. I've read up to here. Let's see some common thread. And this is the part where this video actually begins. So what is an on-path attacker? The on-path attacker place themselves between two devices, often a web browser and a web server, and intercept, modify communication between them. Okay. An attacker can collect information as well as impersonate either of two agents. In addition to websites, these attacks can target email communication, DNS lookup, public Wi-Fi networks. Okay. You can think of on-path attacker like a rogue postal worker who sits in post office intercept letter between two people. Okay. What is meant by rogue? Let's search for it. Google gives the best definition. And here we got no definition. Rogue is a dishonest or unworthy thing. So very simple. Okay. Next. In more modern example, an on-path attacker can sit between a user and a website they want to visit and collect their username and password. This can be done by targeting the HTTP connection between the user and the website. Hijacking this connection lets an attacker act as proxy, collecting and modifying information being sent between user and the site. Alternatively, the attacker can steal user cookies, small pieces of data. We know what a cookie is. These stolen cookies can be used to hijack a user's session. And on-path attackers can also target DNS server, domain name, and keep remember, guys, that DNS is a very good topic for the interviewer. Actually, the from the home whom I interviewed by has asked me questions of the DNS server right after visiting my channel because I have a lot of videos targeting DNS as well. So he visited my channel. He seen that I have a content related to
Hello,
DNS.
I am Ashwin with over 5 years of teaching experience as a home tutor. I am proficient in Cisco.
So he asked me what actually DNS is. So I told him, and the interview was mostly positive, but the result has not came yet. Okay? Next is email hijacking. So the another common attack is email hijacking, in which on-path attackers use to infiltrate email server by putting themselves in between email server and the web. Once this server is compromised, attacker can monitor email communication for various purposes. One such scam involves waiting for a scenario where one person needs to transfer money to another. Example, the customer paying a business bill. Attacker can use a spoof email address to request the money to be transferred to an attacker's account. Email will seem illegitimate and incautious. Innoxious. The pronunciation of this. Innocuous, which means not meant to harm or upset. Innocuous. The email will seem legitimate and innocuous to the recipient. Sorry, there's a typo in my last email. My account number is this. making this attack very effective and financially devastating. In 2015, a cybercrime ring in Belgium used email hijacking to steal over 6 million euros from various European companies. And why it is risky to use public Wi-Fi network? On-path attacks are frequently perpetrated over Wi-Fi network. Attackers can generate malicious Wi-Fi network that either seem harmless and are clones of legitimate Wi-Fi network. Once a user connects to the compromised Wi-Fi network, an on-path attacker can monitor the user's online activity. Sophisticated attacks may even redirect the user's browser to create fake copies of the legitimate. Okay, so you can be a prey to man-in-middle attack if you use public Wi-Fi, because there may be rogue Wi-Fi's. Rogue Wi-Fi's are the Wi-Fi's. For example, if I think to explain this, it is simply the fake Wi-Fi. Uh, Presenting it as a genuine Wi-Fi. For example, if your airport Wi-Fi goes like yes, so it is a legitimate Wi-Fi range of airport which says Air India, for example. Okay, and you are here. So your phone has a tendency to pick the network that is more closer. The more proximity the network has, the more your phone tends to connect. So it is an original broadcast point of the Air India, and here is a hacker sitting in between, and he is broadcasting another network. So you are highly likely to connect to this Air India because the Wi-Fi can have SSID, whatever you want. So if this has an SSID of Air India and this also has an SSID of Air India, your phone or even your mentality tends you to connect to this Air India because it has a higher network range, it has a great signal strength, and that's why you become prey to the man in middle attack. Man in middle attack, middle, MIM attack. Next, what are the ways to protect against the on-path attack? The on-path attackers use a number of methods, and there is not an all-in-one solution for these attacks. One of the most fundamental ways to protect is to target HTTP traffic. It's to adopt an SSL or TLS, which secures connection between users and web services. Fortunately, this is not a foolproof solution, as more sophisticated on-path attackers can work around SSL and TLS. To further protect against this kind of attacks, some web services implement HTTP strict transport security (HSTS). Okay, so it's a new thing, HSTS. Let me write it. HTTP strict transport security. It. Okay. So which forces the secure SSL TLS connection with any browser, blocking any unsecured HTTP connection and also preventing cookie theft. Okay, and we do have a blog about this on here, and somehow somewhere in future we will sure learn that. Next is authentication certificate, which also can be used to protect against these attacks. An organization can implement certificates based authentication on all their devices. Only users with properly configured certificate can access their system. To prevent email hijacking, secure multi-purpose email extension. Okay, SMIME, multi-purpose email extension. Copy it. Uh, we are getting a whole lot of abbreviations in this book. I am very happy about it because I love abbreviation. Pure multi-purpose internet mail extension. This protocols encrypts email and let users digitally sign emails with a unique digital certificate, letting the receiver know that the message is illegitimate. Message is legitimate. Individual users can also protect themselves from on-path attack by avoiding submitting any sensitive information on public Wi-Fi. Sensitive information may include banking details, your passwords, your numbers, etc. If you just need to browse the website, use a VPN. and just do your browsing and try to switch to on device network rather than using Wi-Fi. And time to switch where we were. Common threads. What is buffer? Let's say buffer overflow is an anomaly. Normally, matlab, what does it mean? Select it. Okay. Anomaly
Anomaly.
means strange, something that is different from normal. Okay. Buffer overflow is an anomaly that occurs when software writing data to a buffer overflow overflows the buffer capacity, resulting in adjacent memory location being overwritten. In other words, too much information in a container that does not have enough space, and the information ends up replacing data in the adjacent container. For example, this is the buffer of 8 bytes. And we do have 8 bytes here. 1, 2, 3, 4, 5, 6, 7, 8. And then we have an overflow. So it was the another data, but has been overflown by the data entered here. So what's a buffer? A buffer is an area of physical memory location used to temporarily store data while it is being moved from one place to another. These buffer typically live in RAM memory, random access memory. Computers frequently use buffer to help improve performance. Most modern hard drives take advantage of buffering to efficiently access. Many online services also use buffer. Buffer are frequently used in online video streaming. When a video is streamed, the video player downloads and stores perhaps 20% of the video at time in buffer and then streams from that buffer. This way, minor drops in connection speed or quick service disruption won't affect the videos. And buffer is the reason when you turn off the internet, your YouTube videos keep playing for another 1 minute. And this is also the reason, even if your data has finished, you will find that the half of the YouTube shorts or the Instagram reels are already being loaded, and you are still able to scroll few reels from up and down. You can see that, and you can observe this buffer thing. So buffers are designed to contain specific amount of data. Unless the program utilizing the buffer has built an instruction to discard data when too much is sent to the buffer. The program will override data in the memory adjacent to the buffer. Buffer overflows can be exploited by attackers to corrupt software. Despite being well understood, the buffer overflow attacks are still a major security problem. Government cybersecurity teams in 2014, a threat known as Heartbleed posed hundreds of millions of users to attack because of a buffer flow, a vulnerability. So it's that much. Even in 2014, we are now after a decade in 2024, at the end of 2020, and it's still an issue. How do attackers exploit buffer overflow? Attacker can deliberately feed a carefully crafted input into a program that will cause the program to cause havoc and store the input in a buffer that is not large enough, overwriting portion of memory connecting to the buffer. Okay. If the memory program is well defined, the attacker can deliberately overwrite areas no contains executable code. The attacker can then replace this code with his own executable code, which can drastically change how the program is intended to work. For example, if the overwritten part in the memory contains a pointer is a C concept. Sorry for this sneeze. Okay. So if the overwritten part in the memory contains a pointer is a C language concept, which is an object that points to another place in memory. The attacker's code could replace the code with another pointer that points to an exploit payload. This can transfer control of the whole program to the attacker's code. And who is vulnerable to buffer overflow? Certain coding languages that are C, C++, have the high vulnerability since they contain no built-in protection against accessing or overwriting data to them. Windows, Mac OS, Linux all contain code written in one or both of these languages. Modern languages like C Sharp, Java, Perl have built in features that help to reduce the chances of buffer overflow, but cannot prevent it altogether. So, data can still be overwritten, buffer can still be overwritten in Java, Perl, or C Sharp as well, according to the article. Okay, so how to protect against the buffer overflow? Luckily, modern operating systems have runtime protection, which help mitigate the buffer overflow attack. First is address space randomization. Randomly rearrange the address location of the key data of a process. Buffer overflow attacks are generally relying on knowing the exact important location of the important executable code. Randomization of address makes that impossible. Nearly impossible, not exactly impossible. Next is data execution prevention, which marks certain areas of memory either executable or non-executable, preventing an exploit from running code found in a non-executable area. I didn't get it. Data execution prevention marks certain areas of memory. Okay, now I got it. Uh, Actually, you have to make certain executable by passing the chmod command plus x, entering the executable permissions to a file in Linux. That is due to it want to prevent some data execution, and it is under the program of data execution prevention. Now, software developers can also take precaution against buffer overflow vulnerabilities by writing in language that have built-in protections or using special security procedures in the code. Despite precautions, the new buffer overflow vulnerabilities continue to be discovered by developers, sometime in the wake of a successful exploitation. When new vulnerabilities are discovered, engineers need to patch the affected and ensure that the users of the software get access to. And now we have different types of buffer overflow attack, and it does demands section of it. Just well have different forms of buffer overflow. I think I should make it slightly larger. Now I don't need any map. And so the first is, what is first? Stack Overflow. I think this is a website. Stack Overflow attack. This is the most common type of buffer overflow attack that involves overflowing a buffer on a call stack. If you recall in my JavaScript video, we know what a call stack is and a heap stack is. Okay. So the call stack is where the program that is currently running is being stacked. The code, the functions are being stacked to be executed. And the second is heap overflow. Heap overflow. I don't think I need to write attack. So heap overflow. Okay. And even I don't think that I need to write the overflow again and again. Third is integer integer overflow attack, and finally the fourth is Unicode overflow. Let's go one by one. In an integer overflow, an arithmetic operation result in integer that is too large for the integer type, which it meant to store. This can result in buffer overflow. Lastly, the Unicode overflow. Unicode overflow creates a buffer overflow by inserting Unicode characters into an input and expect ASCII character. And ASCII and Unicode are encoding standards that let computer represent text. We know that. For example, letter A is represented by the number 97 in ASCII, while ASCII codes only cover letter from the Western language. Unicode can create a character for every written language on the earth. Because there are so many more characters available in Unicode, Many Unicode characters are larger than the ASCII character. Okay. And here we have explanation of heap and what was the another stack. So computer rely on two different memory allocation models known as stack and heap. Both live in computers RAM. Stack is neatly organized and hold data as last in first out model. Okay. And I do believe that I need to copy it. The stack is neatly organized. Last bit of the piece comes out, kind of like last would okay will be first to be fired. Good. Keep contained. Okay. Sorry, it was the stack. Stack and I will paste it here. Now I will explain the heap. Okay, and the heap is a disorganized pool of extra memory. Data does not enter or leave heap in any particular order. Accessing. Okay, so stack, as the name represents, is a stack of data. So we can represent it as table. Okay, and the example says that it is like a bullet or the magazine of a bullet. For example, in a gun, this is not a very good drawing of gun, but it is what the gun looks like. So if we insert a magazine, the last going in will be first fired out. So stack works in the same way. Suppose we put some data in stack. So this is the first data and it is my name. So the first thing that is being called by stack is my name. So this is how the stack works. While heap does not have any particular order. So heap is like a sack of data, sack or bag of data. So everything comes in it and it is randomized. So suppose if someone puts hand and he don't know whether the my last name, my first name, my age, my task, whatever they come in the bag. Hence, heap is generally reserved for the larger pieces of data that a programmer wants to manage explicitly. So explicitly means he have to search, he have to uh, write some validations, write some check in order to get the access data correctly. While accessing the memory from a stack is way faster because it is organized. And this is how my explanation of the heap and stack goes by. Let's see the next. What is the next page? Is cross-site scripting, which is XSS. Why? Okay. Yes. What is cross-site scripting? The cross-site scripting, in shortly known as XSS, is an exploit where an attacker attach code to a legitimate website that will execute when the victim loads the website. And that malicious code can be inserted in several ways. Most importantly, it is either added to the end of the URL or posted directly on a page that represents the user generated content. In more technical terms, the cross site scripting is a client side code injection attack. Okay. For example, the attacker sends a script injected link to a victim. Okay, he is simply emailing something. Then the victim clicks on the link and the legitimate website does loads. But along with that, JavaScript code is also running on the browser and will tracks and sends the private data to the AI. So client side code is a JavaScript code that runs on a user's machine. In terms of website, the client side code is typically code that is executed by a web browser and after the browser loads a web page. In contrast to server side code, which executed on host web server, the client side code is very useful with interactive web page. The interactive contents runs faster, more reliably since the user computer does not have to communicate with the web server every time there is an interaction. Browser based games are the cross platform for client side code, and the client side code can ensure the games run smoothly regardless of the connectivity. Code that runs client side is very popular in modern web development and utilized on modern websites. Since cross site code is a staple of modern web, cross site scripting has become one of the most frequently reported cybersecurity vulnerabilities. And is it hit the major websites such as YouTube, my daily food and butter, the Twitter, which I don't use that often, and Facebook, which is a kind of a vintage website right now. So, what is the example of cross-site scripting? One useful example is that they have unvalidated comment forums. In this case, an attacker will post a comment consisting of executed okay. These tags tell a browser to interpret everything between the tags as JavaScript. Once the comment is on the page, when any other user load the website, the malicious code between the script tag will be executed and they will become a victim of the okay. Unvalidated comment forums. This is the masala, or this is the spice of initiating a cross-site script. Is there any other way? JavaScript cross-site scripting attacks are popular because JavaScript has access to some sensitive data that can be used for identity theft and other malicious purpose. For example, JavaScript has access to cookies. An attacker can use the accessor attacks to steal a user cookie and impersonate them online. JavaScript can also create HTTP requests. JavaScript can be used to establish sockets and which can be used to send data. Additionally, client-side JavaScript can also help an attacker to gain access to API that contains geolocation coordinate, webcam data, and other sensitive information. As soon as the victim loads a web page, the malicious code copies the user cookie. The code or the cookie then sends an HTTP request to attacker's web server and stolen cookie as the body of its request. The attacker can use these cookies to impersonate users on the website for the purpose of social engineering attack or even access to bank account number and other sensitive data. And this is the same reason why a YouTube session or for example, I have logged in this YouTube account. This login information has directly been transferred. It is like transferring or giving my computer to some other person. Okay, and cookies are temporary login credentials that are saved on user computer. Sharing a cookie means sharing your computer with someone for a specific period of time. Cookies do come with a time to live, and I don't know, but I am very sure that it can be modified in order to gain a permanent access to the attacker. For example, as soon as you're not changing your password, and it had been happened to the Linus Tech Tips, as I know. For example, when a user logs into a site like Facebook, the site gives them a cookie so that if they close the browser and go back to Facebook later that day, they are automatically authenticated by the cookie and won't need to log in again. So, what are different types of cross site scripting? And this is reflected and other is persistent. Let me write these two ones. Whether the recording is being, yes, I am being recorded. Okay. Cross site script. Cross site scripting. First is reflected, second is persisted. The most commonly seen cross-site scripting attack with a reflective attack is the malicious code is added onto the end of the URL. Often this okay. Okay, user equal to script. Here is some bad code. Although the first part of URL looks safe and contains the domain of a trusted website, the code injected into the end of the URL can be malicious. Next is persistence. Okay. Oh, next is the persistent, which means the attacker is entering comment on the website, kind of. If site does not properly validate, okay, reflected. So you can say that simply code injected in the URL, and for persistent we can say code injected in the text section of the website, section of the website. I also want to write that the invalidated, in the invalidated invalidated text section of the website. Because now it being clear. Okay. How to prevent cross-site script? There's no single strategy. Different types of application requires different level of protection, and some measures can be taken. If possible, avoid HTML inputs, HTML in inputs. One of the very effective way to avoid persistent is to prevent users from posting HTML. Okay. Simply use validations. Validation rules can also set to reject any tags or characters commonly used in cross sites, such as enclosed script tags, etc. Okay. Okay. So validations like only submitting the characters, not a special thing, just say this angular brackets, etc. This should not be able to submit, hence preventing the cross-site script. Next is sanitizing data. It is quite like the validation, but happens after the data has already been posted on the web server, yet still before it is displayed to the another user. There are several tools in order to sanitize the HTML and filter out the malicious code injection. Next, taking security cookie measures. Okay, what is it? It is the cookie handling that can mitigate cookie theft via cross-site script, and it can also be tied to a particular IP address so that the cross-site scripting attackers cannot access. And next is our WF rule, Web Application Firewall Rule, which employs strategies that block strange requests to the server, including cross-site scripting. Cloudflare Web Application Firewall, often turnkey installations. What this turnkey means? Turnkey. Turnkey. Complete and ready to use, immediate use. Okay, from the cross-site script. The DDoS attacks, SQL injections, and other common threats. And we were about to study the SQL attacks as well. So let's see what the next topic is in our shed. Common threats. Next is cross-site request forgery. Let it look.
Turnkey.
Now, after a long display, cross-site request forgery. Let me write this. Copy it. Cross A cross-site request forgery attack is a type of confused deputy cyber attack that tricks a user into accidentally using their credentials to invoke a state-changing act such as transferring fund. Okay, confused deputy cyber attack that tricks user into accidentally using their credentials, changing their email address for some undesired. Okay, okay, okay. Let's see how this attack works. Attack focus on targeting state changing request, which refers to the type of request that result in data being changed from one value to another. For example, a targeted request might make a purchase or change a value in account. Interestingly, this is a blind attack and does not return data to the attacker, making it a poor choice for data theft. Okay, so here is four step. Attacker create a forged request. When run, it will transfer $10,000 from a particular bank to an attacker's account. Attacker embeds the forged request into a hyperlink and send it out in a bulk email, and also embeds it into website. Then victim clicks a link on the website, which is placed by attacker, resulting in the victim making a request to bank to transfer 10,000. The bank server receives the request, and because the victim is properly authorized, it treats the request as a legitimate and transfer the bank server. The bank's web server receives the request. Okay, okay, I got it. It is kind of cross-site attack, but this time the user clicks on a link. So how it is different? Exactly how it is different. The attack, the methodology is different, but typically have the following characteristics. They exploit a website that relies on user identity. They trick the user browser into sending HTTP requests to the targeted site. And they involve using HTTP requests that have side effect and do not have the proper CSRF protection. Okay. And after reading this, I will certainly try to explain or explain myself what's the difference between XSS and CSRF. Okay, so different HTTP verb have varying vulnerability to CSRF attack, resulting in variable protection strategy. This is due to the way that web browsers handle the verb differently. HTTP GET requests have embedded parameters, as those in inside image tags, which can be manipulated and exploited. Typically, the GET requests do not modify state, making them ineffective as target of CSRF for a properly implemented web application. Post request is used to change data, resulting in increased need of protection. To end this, web browser implements security measures called SOP, Same Origin Policy, and Cross Origin Resource Sharing, CORS, which contains the cross origin security policy. I used to develop this or implement this on my website when I was learning the React. SOP allows for requests from the same origin, or the CORS allows only certain type of requests to come from different origin. The combination of these implementations helps to prevent CSRF attacks, among others, by limiting the ability of requests or web pages to interact with a different origin. Other HTTP verbs such as put and delete can only be run using the SOP and CORS, mitigating many cross-site ISV. So, though it's uncommon, some websites will explicitly disable these security measures, and it's possible to disable them inside of a web browser as well. How can cross-site request forgery be mitigated? The most common methodology for mitigating CSRF attack involves using anti-CSRF token. And before starting studying how the mitigation of this, I just want to uh, explain you how we can prevent it. And yes, so we were talking about accesses, the cross-site scripting, and what was it? CSRF. CSRF. So the difference between these two, the cross-site scripting has a two variant. Okay, the first is entering some text in the comment section. Okay, and the second thing is when you using the URL HTTPS, you have entered a code in the script tag. Okay, okay. What it will do, the final result, and this is the two methodology used by accesses. Okay, and the final result is the website loads. In both cases, the data will be sent to the attacker. So attacker can actually analyze the information sent by the website, or sent by or done by the things or the activities done by the user. Okay, but in CSRF, The attack is done using email or by simply sending a link. Then user will click the link www something something.com. The user will click the link, and this is quite like the second method of accesses, but it directly does not deliver a payload to attacker. It actually performs some task. For example, transferring bank money to someone else account. It may be of attacker account or someone relative to an attacker, who knows. But it is a program where, because the website thing in this scenario, the website think that the actual user is performing the function, but an script is performing a function uh, of those or in on behalf of the user. Okay, hence the ultimate monetary benefit get to the attacker. But here the attacker is not getting any monetary benefit but the data benefit, and sometimes even the data is more valuable than the money. So we can say that the XSS is much more, far more superior than CSRF, but both are attacks and both may lead to heavy loss to an user. So that's all from my side. Let's see how it can be mitigated. First is synchronizer token pattern. When a user visits a web page, such as a bank web page that allows the transfer of funds, the bank's website embeds a random token into a form. When user submits the form, the random token is returned and the bank is able to check that if the two token match. If the token match, the transfer occurs. The attacker has no way to access the random token value created in the web page, because as I just told you that the JavaScript is not sending any payload to the attacker. And if they request the page, the same origin policy would prevent the attacker from reading the response. The downside of this method mitigation is that it increases the burden on the server side to check the validity of tokens with each request, which can also create issues if a user has multiple browser windows or other condition that involves software making the request. Expanding the scope of the token to be session per instead of per request, some of the difficulties can be avoided. And next is cookie to header token. Another method involves issuing a cookie to a visitor's web browser that contains a random token. JavaScript operating on client side will read the value of the token in the cookie and copy it into an HTTP header and will be sent with each request. If the genuine request is sent from the user, the value in header can be verified by server. Any other instances will fail. Okay? And by using custom rules through WAF, users are also helped to prevent certain CSRF attacks. And this is the article to explore that. And finally, something which is known as confused deputy thing, which I read here. Here, where I read, yes, confused deputy cyber attack. Let's see what is it. Confused deputy refers to a computer program that is fooled into misusing its authority. The risk associated with this sort of vulnerability is why capability based security helps reduce the risk associated with the misuse. When installing software, for example, most computers today require the user to log in. This prevents code from being executed unintentionally when the user accidentally use their authority to authorize an int. Okay. So the thing that pops when you install the application that this program wants to make changes to your computer is actually related to this thing. Okay. And what UAC, user access control, UAC window. Let me show you what I'm talking to. What I'm talking about. Uh, UAC Windows. Windows. This is the thing. Do do do. I also remembered the sound how it pops up. Do do do. And this is how this is really first video after a while. Let's see after a while how last when I posted the video 13 days ago, and this is how after 13 days my video ends and being posted. Thank you very much for joining me this session. Thank you. See you again.